This is question 23 from section 1 of the 2018 ENGAA paper. So we're given this question. The height of some isosceles triangle is 8 centimetres, and we're told it's 3 centimetres greater than the base, so i.e. h is equal to b plus 3. And the sloping side S has a length of s centimetres. And we're told the area of the triangle in total is 14 centimetres. And we're asked, in what range does S lie? So is S between 5 and 6, 6 and 7, 7 and 8, 8 or 9, 9 and 10, or 10 or 11? So how do we go about this? We've got all this information here. It's a bit of a mess. How do we start? Well, this is the key part. We're given the area, and this is the only numerical quantity we really know. It's the only property we certainly know about the shape. So let's try and come up with a formula which is equal to this and go from there. So we do know one. So 14 is equal to half times the base times the height. But this isn't particularly helpful in its current form because we've got two variables times together equal a number. That's not particularly helpful. We need it really in one variable. So we know the height of an isosceles triangle, though, is 3 centimetres greater than the base. So we know h equals b plus 3, right? So we can substitute that in. And now, if we times through by 2, so we get 28 on this side, expand this bracket out, and then minus the constant from this side, we get this. We can rearrange this to get to a standard quadratic. And this is great because we know how to deal with these. So using the quadratic formula, we get b equals minus 3 plus minus the square root of 3 squared minus 4 times 1 times minus 28 all over 2. And first things first, let's try and fix this mess here. So 3 squared is 9 and 4 times 28 comes out as 112. So we get minus 112, so plus 112. So we get to this. But 9 plus 112, that's great, that's 121, which you'll probably recognise as a square number. It's 11 squared. So, b is equal to minus 3 plus minus 11 over 2. Now, we've still got this plus minus here, but does that minus make sense? Minus 3 minus 11 over 2, that's minus 7. Does a length of minus 7 make sense? Not really. So, we don't have to deal with a minus, we can ignore that now. We've got the plus, and if we have plus, this comes out as 4. So we have b equals 4, and so now let's try and find s. So we worked out b as 4, so we've put 4 in here and 7 in here because the height is b plus 3. And now we've just got to work out s. So how would we like to do this? Well, it'd be nice if we could get some kind of right-angled triangle where s is a side of. And we can. So if we take the point here, just draw a vertical line down to bisect this, perpendicular bisector, like this. We get this is a right-angled triangle here, with the sides of 2, because it's half of this length, and 7, because it's the height here. And we can work out s from here. So by Pythagoras, s squared is equal to 7 squared plus 2 squared. And we can work these out, so 2 squared is 4, 7 squared is 49. And add those together, we get 53. So, but remember, we don't actually have to work out exactly what s is. We're asked in what range does s lie. So, recall that 7 squared is 49 and 8 squared is 64. And from this, because 53 is between 49 and 64 clearly, then s must be between 7 and 8. And so we know our answer is C as required.